Let's see one more problem. Given a magnetic circuit shown in the figure has n turns of coil, okay? N turns of coil. A big magnetic circuit is having n turns of coil, okay? Electrical analog for the magnetic circuit shown in the figure is, okay? These are the shown figure here. We are asked to choose the correct one, which is the correct analogous magnetic circuit analogous to electrical circuit, okay? Analogous means similar, okay? Friends, we know that the magnetic circuits and electrical circuits, okay, are very much analogous, means similar to each other, okay? So in a basic, let's see, in a basic electrical circuit, what are the required basic parameters to draw electrical circuit? We need a voltage source, okay? We need a first voltage source, then this source produces a current, okay? In order to limit those current, this wire offers some resistance, okay? This resistance limit the current, okay? In order to flow the current, what we use? Wire, okay? In a similar way, this is a magnetic circuit, okay? What is the source? What is the analogous parameter here in the magnetic circuit? Ni, MF, okay? Ni. This is analogous to voltage, okay? This will produce a flux. Here voltage produces current. This MMF will produce flux, okay? These are the paths shown here for the flux. This is flux, okay? So this will produce flux, okay? In order to limit those flux, this core offers some resistance. We call it reluctance in magnetic circuit, okay? So this is reluctance, okay? Reluctance is offered to magnetic flux, okay? In electrical circuit, for the flow of current, we use wire, okay? For the flow of current, we use wire. In magnetic circuit, what we use? We use core. We can see here, this is the core, okay? This is the cross section area of core, this much thickness, okay? This is the core. We provide core because core provide less reluctance path as compared to air. That's why we prefer iron core for the flow of current. For the flux. In electrical circuit, we use wire for the flow of current, okay? So we use core for the flow of current, flux. Here we use wire. So this was the required information to draw the magnetic analog to electrical circuit. Okay. Now let us draw Ni. We will draw Ni. Okay. In place of E. What this MMF produces? Flux. Okay. The direction of if this is the polarity, direction of flux will be like this. Okay. Now reluctance R. Okay, this is a core. Okay, this is the core, which is compared with this core is compared with the wire. Okay, so this is the complete electrical analog for the magnetic circuit. Okay, so which is the correct answer? This one. Okay, in this flux is in wrong direction of flux is shown, and this is wrong. This is wrong. This is not N phi. This is flux. This should be flux. This should not be current. This should be Ni naught. So this is the correct answer. Okay. So we can see that how much similar they are. Thank you.